Question 44 says that the graph of y equals the absolute value of x minus 6 is in the standard xy coordinate plane. Which of the following transformations, when applied to the graph of y equals the absolute value of x, results in the graph of y equals the absolute value of x minus 6? As far as the answer choices go, F through J all seem very similar. They're all translations in terms of 6 units. The difference is whether it's to the right or left or up or down. And then answer choice K has a reflection across the line x equals 6. In terms of answer choice patterns, F and G kind of are opposites in the sense that they're going in opposite directions, and the same thing with H and J. So it seems like they might be expecting us to make a mistake either way with the direction, so we'll want to be extra careful about that. The ACT math concepts involved in the prompt are absolute values as well as the XY coordinate plane, and then the big thing is the idea of graph transformations. There are a couple different ways that we can solve this question. I'm going to type them out over here. The first way we can solve this question is just by graphing the functions and seeing what the transformation is. And actually I'm going to make this is going to be the concrete way. And then the more formal way is to use our understanding of graph transformations. All right, so with this first way of graphing, let's first reread the question and get a sense again of what it was asking us for. So they're telling us that there's this graph of a particular function that is in the XY coordinate plane, and they're asking what would we have to do to this original absolute value function to result in that new graph. And and the answers are basically telling us we're going to have to move to the right or the left or up or down, etc. So one thing we can do is just graph that original function there, which is y equals the absolute value of x. And I have a bunch of stuff here already, so I'm just going to clear this out. So now the next step is to actually put this into the calculator. To get an absolute value symbol, we can go to math on the TI-84 and then go to num. So we go to the right, and then there's the first thing, ABS, stands for absolute value. We put that in, we get our little absolute value bars, and we'll put in absolute value of x, which is the original function. And now let's also graph this other function, which is the absolute value of x minus 6. And then I'm going to do zoom 6 for the standard graphing window. Okay, and we see that the first graph there is the blue one. We can go back and see the blue line is for the absolute value of x, and then the red one is the x minus 6 one. And so the question was asking, again, let's just move this calculator down, which transformation applied to the blue one results in the red one. And we can see that relative to the blue one, the red one has shifted over to the right. So we've gone 1, 2, 3, 4, 5, 6 units over to the right. So the correct answer here is going to be translation to the right, 6 coordinate units. Let's now look at the formal way of solving this question, which would be to use our understanding of graph transformations. And specifically what they're testing us on here is this idea of translating to the left or right or up or down. And so I'll write out what we need to know about that. So this is basically vertical and horizontal shifts of graphs. So for a vertical shift of a graph, what's going to happen is we'll have a function like y equals f of x, and then we're going to add or subtract a constant c. And this will cause the graph to move up or down by c, depending on what it is. We'll move up or down by c. And then for horizontal shifts, we'll write this out, horizontal shift of graph, we're going to have a function, but instead of adding or subtracting the c to the outside of the function, we're going to do that to the x value directly. So it'll look like this. And put some spaces there. So the c is adjusting the x directly. And what this is going to do is the graph will shift horizontally by c, depending on what it is. And to give some concrete examples for this, I'll just write it out over here. So for example, if we had like y equals f of x plus 5, this is going to result in a vertical shift up by 5. On the other hand, if we had y equals f of x minus 5, this is going to be a vertical shift down by 5 because we're subtracting from the function as a whole. On the other hand, if we had y equals f of x plus 5 like this, we're adding that directly to the x. And what's a little bit counterintuitive about horizontal shifts is that you might think this would go to the right by 5 because we're adding it, but this actually goes in the opposite direction. So this goes to the left by 5. And vice versa. If we were subtracting 5, it would go to the right by 5. So with this understanding in front of us, we can go back to the question and see that we were starting out with this function right here, and that the function is being shifted here by subtracting a 6 directly from the x. So this is going to be an example of a horizontal shift. And as we said over here, when we subtract, that actually makes it move to the right, a little bit counterintuitive. So that is why answer choice F is correct in the formal way, as we saw just by graphing it. Let's take a look at the wrong answers. Answer choice G, as we said, is the opposite of F. And there's a couple different ways someone might get that. That could reflect the mistake of not knowing that this horizontal shift actually goes to the right. Another mistake it could reflect is knowing that it goes to the right, but then losing track of the order of comparison. So if we had graphed it or something and accidentally mixed up these graphs, we might have thought that the red one was the starting one and then said, oh, it's shifting to the left 6 units. As far as H and J, those incorrectly apply the type of shift that we're doing. So it's possible to look at this and think it's like a linear equation or something instead of this absolute value, and mistakenly think that we're doing a vertical shift. And then finally for K, this idea that it's a reflection across the line x equals 6, that could reflect if we had graphed it and we see that the graph of the red one, it's actually symmetrical around the line, the vertical line x equals 6. And so someone might see that answer and they're like, oh, it's reflected across that line. The problem with that, though, is that they're asking for the transformation that would turn the blue one into the red one. So they're not asking for an actual property of the red one. And even if they were asking for a property of the red one, it would be symmetrical around the line x equals 6 and not a reflection across the line x equals 6. Let's go ahead and type out what we ultimately needed to know for this one. I'll write it right here. Ultimately needed to know. And we saw that when we graphed this thing concretely, that we really didn't need to know anything at all. So I'm just going to write that. If we graphed the functions, we didn't need to know any formal math really. And that leads us to the ultimate takeaways for this question. One thing about this type of question is a lot of students, when they're beginning to prepare for the ACT and don't know all the different ways that they can approach questions, a lot of times it won't even occur to them that they can just graph this thing, and then they'll get stuck on this idea of trying to apply their formal knowledge of graph transformations. And sometimes they know them and are confident with them, and so it's an easy question. But other times they'll be more shaky with the material. So if it occurs to us that we can actually graph this, the question becomes much, much easier and completely solvable in that way. And we could also, if we're feeling shaky about the material, we can use the graphing as a way to double check our understandings. Part of the challenge here is just the realization in the first place that we can actually graph it. So we want to get used to what is the wording in this question that allows us to take that approach. And a big flag is just the mention of the graph in here and here. So when questions use that type of wording, consider the possibility that you might just be able to plug into your calculator and visualize it. In terms of how easy this question becomes when we graph it, it fits into this overall pattern that we see in the ACT, which is one where they don't like to give pictures very much, because obviously if they had given us pictures here of these graphs, then this question would be super easy. So once again, we see this theme of taking something that's kind of abstract, making it concrete. And finally, if you want to see other questions from this particular test that can be graphed on the calculator and solved that way, check out question 4, 54, 55, and 59, as they all can be solved in a somewhat similar way as this one. Now let's go ahead and go on to question 45.